6 entire mixed radicals. So this is where we take a step further. If you do really well at this, you're not only great for Math 10. Again, I know I've said this a lot. You probably don't care. Math 20's unit test that's going to be on Friday is on this, essentially. Simplifying radicals. Okay? So you're going to see the basic ones. They obviously get a little bit harder next year, but for the most part, we're breaking down radicals. We're simplifying them. And remember, yesterday I talked about, or Friday, I talked about when you simplify radicals, guys, the value does not change. That value of that radical is still the same. The same idea with square root of 25, square root of 25 is the same value as 5. So if you put square root of 25 in your calculator, it'll kick out 5. Obviously, 5 is 5. They're the same value. So when you're doing these things, you can always check your work. If I say make this the simplest mixed radical possible, and you do it and you have two different values, you messed up. Okay, so take advantage of that when you guys are doing your quizzes / tests. Okay, so this is just review. Remember, we can multiply radicals with the same index. We can divide radicals with the same index. Index, remember, that's the square root, cube root, fourth root. Okay, so we've already talked about that. So now we're going to do a little bit of the reverse. So this is how you break down radicals. I'm going to get you to think about some things too, just intuitively, in terms of understanding why we're doing what we're doing early. So for example, I'm going to break 24 down to 4 times 6. Okay, and then we're going to break it to 4 and a 6. What's the square root of 4? 2. You just did it. 24 simplifies to 2 root 6. Does it? Well, why did I pick 4 and 6 rather than 3 and 8? I'm not going to tell you that now, but that's what I want you to be thinking about. Why didn't I go 12 times 2? Why didn't I go 8 times 3 for 24? Why did I pick 4 times 6? That's the question you want to ask yourself. So 18, here we go. We're going to go 9, and then we're going to go 9 times 2. That's what 18 makes. Square root 9 times square root 2. Square root of 9 is 3. You did it again. Root 18, simplest form, is 3 root 2. Again, same question. Why did I go 9 times 2 instead of 6 times 3? I don't know either. I'm just asking questions. Yeah? No. Good question. So if you did pick 6 times 3, you will not get the same answer. Good question. Anyone want to try to answer that? Chloe?
You want one that can be a perfect square?
Correct. We want one with a perfect square. This one had 4. This one had 9. Those are nice because square root of 9 is 3. Square root of 4 is 2. We can rewrite those as nicer numbers and no more radicals. So in general, as you're doing these, and we'll get to it in a second, okay, kind of spoiler alert, okay, you want to always find the biggest perfect square that goes into the number. Okay, we did smaller numbers. The biggest perfect square that goes into 24 is 4. Okay, the biggest perfect square that goes into 18 is 9. Okay, if you have the biggest one, then I know that when I pull it out, it'll make the simplest mixed radical. Okay, I'm getting way ahead of myself, but this is a mixed, or excuse me, that's an entire radical. This is the mixed radical. Mixed is with a coefficient and a radical. Okay, I'm throwing out a lot at you right now. We're going to expand on it. Okay, the fraction one, whenever you get fractions, guys, just go ahead and write it in 2 pieces. Well, root 11 is root 11. I can't do anything with that other than make it a decimal, but root 4 is what? 2. So we're done. It's root 11 over 2. Let's see if I can challenge you guys. I didn't challenge last class this, but what would I write if I wanted to make that a mixed radical? So technically it's not a mixed radical right now. How could I write it with a number in front but not changing it in terms of the value? Yeah. 0.5? Yeah, 0.5 or 1/2 root 11. So see how we just kind of slid the fraction in front? Because this is a 1/2, right? It's a 1 root 11 over 2. So just pull that 1/2 out. It's root 11. These are the same thing. If you're like, wait a second, you're changing it. Well, no, because if I multiply these, well, what's root 11 times 1? Root 11, 2 times 1, 2. So you can see I'm back to here, okay? I haven't changed anything. So that would be the same case if I had something like this. if I had root 11 over 6, that would just be 1/6 root 11. Do you see what I'm doing? I'm just sliding that 6 over. Is that making sense? That's the way you can write it with mixed. Okay, remember, mixed versus entire. All right, slow down here. Again, you guys ask questions. A lot of you guys see, a lot of you guys put a lot of thought into things. If you have anything that's sparking your mind, just feel free to stop me. Yeah, Andrew?
So, the other way, like root 11 over 2, is that considered entire?
That would still be mixed. It's just I think 1/2 is just a clear view of being mixed, if that answers your question. In the book, when you're doing your problems in your thing today, they pulled it out, so that's why I talked about it. I think I would accept both, though. Okay, so here, use a calculator to approximate these. So who's got a calculator in front of them? All right, Jake, can you put this one in your calculator? Who else? Caleb, do this one. Okay, and then, yeah, Calvin, do that one. Just tell me what they are. It says the 5 decimal places. 5 decimal places. Just whenever you're ready, just let me know. 8.94427. Okay, good. And what did you get, Caleb?
4.4.
So you times it by 2, right?
Oh, I square rooted it by 4.
Yeah, try that. Go ahead. Do you have yours, Calvin?
I got 8.94496.
Okay, I think yours will round to 7 as well. It's probably.
I rounded it. It was 7. It was 0.71 after, so I counted 6.
Well, 7-1 would be 7.
Was it? Oh, yeah, okay.
Yeah.
I got 8.94427.
Okay, so the whole point is they're the same. All 3 of these values are equivalent. Okay, let me show you why. So you put same here. 80, if I break it down to 4 times 20, 4 is a perfect square, right? Square root of 4 is 2 root 20. That's how they got this one. From 80 to 2 root 20. They went 4 times 20. Why is 4 good? Because 4 is a perfect square. Okay, what about the other one? 80 equals 16 times 5. 16 and 5, the square root of 16 is 4. Which one of these is the simplest? The bottom one, good. It's the bottom one because the bottom one, we took the biggest perfect square possible. The other reason why, does 5 break down at all? No, it's just 5 more, about 20. Yeah, a 4 goes into 20 again, so that's why this one's not the simplest. Okay, mixed, mixed. This is entire. This one's the simplest. Okay. So back to kind of what Hassan said. So if you give me 2 root 20 for an answer, you'll miss a little bit of points because we want the simplest answer. Okay, we want the simplest answer. Unless it just says make mixed. If it says make mixed, then that's acceptable. Okay, but if it says simplest answer, you got to go all the way to 4 root 5. Okay, so 80, again, I've already said this already. Root 80 is an example of entire. 2 root 20 and 4 root 5 are examples of mixed. All right, let's keep on trucking here. So I'm not going to read this top part. You can have it for your own, but some examples of entire, some examples of mixed. Okay, so now we're going to talk about converting from entire to mixed, which simply means simplifying radicals. Okay, this is a strategy that I use. I told you guys that you need to know 1 squared through 15 squared in order to be really good at these. If you know those, it's going to be easier to see your number patterns. If you don't, you're going to have to do a little bit of trial by error. It's going to take a little bit longer. It's going to frustrate you, but that's because you don't know them very well. As you figure them out, you'll figure them out. So for example, let's say you had the number, let's say you had number 128. Would I try 25? Do you see that number pattern? I wouldn't try 25 because 25 is only going to go stuff with a 5 or a 0 ending. 128 doesn't fit that. You see what I'm saying? Those type of things you can skip. All right, so to my point here, 108. We're trying to break 108 down into multiples of these guys, the perfect squares. This is my strategy to you. We know that anything over half, so what's half of 108? 54, right? So does 60 go into 108? No. So anything above there is gone, right? We don't care about it. So 54 is my starting point. What's the first number under 54? 49. We know 49 doesn't go into 108. Well, why? I just kind of know because 49 times 2 is 98. If I go another one, I'm way over. Just kind of number sense. How about 36? 36 that's 36 times 3. So that's what I'm saying. The method I use, I kind of cut it in half in my mind, and that's where I start if I don't know. So I go, okay, I'll try 49. Nope, 36. That was it. 36 times 3 is the biggest perfect square that goes into it. That's helpful because now I'm done. Square root of 36 is 6. 6 root 3 is my mixed radical simplified. So again, you're trying to find the biggest perfect square possible. Any questions on that? Do you see what I'm saying? Like last class I got confused when I said that you half it. I'm not halving it and then looking for like numbers to go into 54. I'm halving it for knowing what numbers to try to still go into 108. Okay, last class is like, well, I thought you said you wanted us to divide that number. No, that's to give me the starting point of what to try of these. Okay, so let's try that real quick with 50. What's half of 50? Well, that's bingo. That landed right on one. That's what we want. 25 times 2. Square root of 25 is 5, and then root 2. We're done. Okay. Well, half of 45, it's an odd number, so that's not going to be as nice, so it's just 22-ish. Okay, so okay, that means I'm starting here. Does 16 go into 45? Nope. How about 9? Yeah, that's what I want. 9 times 5. Okay, what's square root of 9? 3. So it's 3 root 5. Sorry if you can't see that. It's 3 root 5 there. Making sense a little bit? Okay, I'm going to pause the video for a second. Try 320. It's a little bit bigger. I want you to try 320, see if you can get it. All right, so what did we get? Who got the 320? Somebody new. Yeah, go ahead, Bree. Okay, so she got 64 times 5. So it's 8 times root 5. Okay, good. Okay, so now I'm assuming, if I heard how many of you did 16 times 20? Anybody do that one? Okay, so 16 times 20 is okay, but that's not the biggest perfect square. So what you've done is you have a little bit more work. Okay, because 20 can be broken down. So that's fine. Okay, you got 4 root 20. But 20 breaks down. Okay, to 4 times 2, root 5. 4 times 2 is 8 again. Okay, that's why you have to find the biggest one. So you should have, by our steps, half of 320 is 160. So you should have tried, you've been right about there. Then just went from there. I wouldn't have tried 144. I wouldn't have tried, I wouldn't have tried 121. I wouldn't have tried 100. So I probably would have tried 81 first. You know 81's barely going to miss because 81 goes to 324, and then it would have been 64. You'd have been there. Okay? See what I'm saying? You don't have to try them all unless you absolutely want to, but that's just kind of the process. Okay? So good. All right, so now these ones, there's a number outside. Whenever there's a number outside, you just multiply it by what you pull out, or what you break it up to. So, for example, 192 is going to break down to what? Let's see if you get 192. So half of 192 is what is that? You got 36. 96, yeah, so 96. So under 96 I want to try. So I want to try 81 first, and then I want to try 64. Okay? As you guys are doing that, you should have got 64 and 3. Now the key thing I want you to understand is we're writing them as products. This is a product. Everybody understand that? So what's the square root of 64? It's 8. So what I have is I have 2 times 8 root 3, which I write 16 root 3 now. 16 root 3 is the solution. Okay. Am I going too fast? Are you missing anything? Okay. Okay, so what about fractions? Are they different? No, remember, fraction's a number. It's okay. So we're going to go 3 over 4. I'll kind of give you guys a little heads up here. It's 16 times 10. The reason I know it's 16 times 10 because 10 can't be broken down. 10 times 1? Nope. 5 times 2? Nope. When I'm saying no, I'm talking about perfect squares. There's no perfect squares in 10. Okay, so that's what it's going to be. So then you have 3 over 4 times 4, because that's root 16, times root 10. 4's cancel. Your answer is 3 root 10. If you're saying why the 4's cancel, well, because it's a whole number, so it's over 1. 3 times 4 is 12. 4 times 1 is 4. 12 divided by 4 is 3. Okay, any questions there? All right. Last but not least, the fractions, guys and gals. The fractions, every time, write them as 2. And then simplify what you can. If I write that as mixed, or as the book would call mixed, you could write it 1/3 root 7 if you'd like. All right, so now we're on the home stretch here. Just when you thought you were getting it, now we're going to flip your brain. We're going to take them from mixed and make them entire. Okay, so we're going to take this 16 and we're going to push it in. So instead of square rooting them, we're going to be squaring them, right? We're doing the opposite operation because we're going the opposite direction. Okay, good, Seth. So we go here. This quick example, 3 root 14, I'm going to write 9, right? Because 3 squared is 9. 9 times 14 is the entire radical, which is going to give me 126. So that's the entire radical from that mixed. So you take what's on the outside, you square it, and put it inside. That's it. Whatever's in there, you multiply it. Okay, I'll do these two, and I'll give you a second to try. Well, C will be pretty easy too, actually. We can do all these real quick. So right there, that's 4. Square it. Root 20. Okay, you can just sit anywhere. All right, here's good. Okay, this one here. Square the 4, 16. Okay, and that'd be 112 for your entire. Just go mixed to entire. And last but not least, the 10 root 6. 10 squared is 100. 100 times 6 is 600. So root 600 there. Okay, now we'll do the ones with decimals and fractions here. Same process, nothing changes. Only one thing changes. We'll talk about C. Okay. So 3/2, we're going to square that. So that's going to be 9/4. That's where we're at. I squared 3/2, so I squared the top. 3 times 3 is 9. Squared the bottom. 2 times 2 is 4. And I put it in the radical. Then I'm going to multiply those. So that's going to give me 9 times 8 is 72 over 4. 72 divided by 4 is root 18. That's the simplest entire radical there. Yeah, we're one page back at the bottom. Okay, so now we're going to square this. 0.4 squared is going to be 0.16. So we're going to have 0.16. Now if you're saying, whoa, I don't know what 0.16 of 50 is, well, we'll use your calculator. It's okay, don't panic. Okay, 50 times 0.16 is going to be root 8. Okay, C is a little tricky because we have a negative there. Can we put a negative inside an even root? No, so what we do is we just don't touch it, okay? We just leave the negative just out here. And we're going to go 25 and 7. The negative just hangs out, okay? Do not push the negative in. Okay, so the negative 175 is your entire radical. All right, 2 more examples. Okay, questions? All right. All right, so this one we're going to order them. Okay, so to order them, what really helps is to make them entire, so they're all the same. Because it's hard to tell when they have different radicands. If they have different radicands, everyone here doesn't really know what root 5 is exactly. Okay, so if we make these all entire, we can see what's bigger. Okay, so what I mean by that is I'm going to go ahead and do, okay, 9 and 5, right? Square the 3, 9. So this is actually root 45. So is root 45 bigger than root 15? Yeah, you can clearly see it now. So when they're all entire, you can just do it numerically. Okay, so same thing here. 25 times 3. So root 75, so that's even bigger. The root 15, I don't have to do anything. This one here, root 4 times 8, root 32. Here, root 64 times root 2. So we're putting it from biggest to smallest. Okay, so if I'm doing biggest to smallest, here's number 1, here's number 2, number 3, 4, 5 in terms of order. Okay, so I would go 8 root 2, because we're going to write them in their original form. 8 root 2 is 1, 5 root 3 is 2, 3 root 5 is 3, whoops. 5 root 3 is 4, no, that's a lie. I wrote 5 root 3. 2 root 8 is 4, and then root 15. All right, last problem, we're just using Phagon Theorem, which hopefully you remember from grade 8. If not, we'll refresh it. Okay, so the problem says, use Phagon Theorem to figure out what the length of AB is. We're trying to figure out this length. The problem is, in order to do that, we need to know what this length is. So it's making us do it twice. Okay, if you forgot Phagon Theorem is a squared plus b squared equals c squared, with this being your hypotenuse. Okay, but if you're given your hypotenuse, you can also write it hypotenuse minus leg squared equals leg squared, which we're going to use that because we're given the hypotenuse here. So for the first piece, because we want to figure out AD, we're going to go AD squared equals hypotenuse minus leg squared. 12 squared minus 8 squared. Okay, if you want to use Phagon Theorem, guys, and you're not used to this, that's fine. What you're going to do is you're going to write this plus 8 squared, and you're going to minus 8 squared. So I'm just saving you a step is all. Okay, I'm not reinventing the wheel or anything. So AD squared is 144 minus 64, which is 80. So AD is root 80. We'll just leave it like that. So now we have the two legs, right? We have 6 and root 80. And so we can figure out AB now. So it's going to be 6 squared plus root 80 squared equals AB squared, which is what we're trying to get. All right, 6 squared, 36. What's root 80 squared? Just 80, right? They cancel. Radicals canceled by squaring, right? So you're just canceling them. 80 plus 36 is 116. So square root 116 is AB. So it wants the simplest radical form and the decimal. So to get the decimal, we can do the decimal right now. We can just square root 116 in our calculator. So to do part B would be 10.77. Okay, but to break it down, somebody tell me, 116, what are you going to try? So half of 116 is 58, so we're going to start there. I'm not going to try 49. 36, nope. 25, definitely not. 16, maybe. Does 16 work? Nope. Okay. 9. Nope. And then, so there has to be 4 if they're really wanting us to break it down. And then what is it? 4 times 29. Okay. Sorry, I'll write it over here. It's 4 times 29. So your simplest answer is 2 root 29. That's your simplest radical answer. 29 makes me feel like I did it right because why? 29 is what type of number? It's prime, and there's no perfect squares that's going to 29. Okay, so that is correct. You also, again, if you did 2 root 29 on your calculator, you should get 10.77 as well. Okay, all right, good work today. A little more questions, but not bad.